Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today the topic is about pull requests, which apparently are very controversial in software development. And to help me with this conversation, I have once again with me Adi. Welcome back.
Hello.
So here's what happened. A few weeks ago, Thierry de Pauw said that, seeing how much you have the tweets here, seeing how much software engineers are attached to pull requests is getting time for the next talk. Pull requests are evil. Now, Thierry has a history of doing these types of talks, and I think he does them very well. The previous one was feature branches are evil, which I also recorded a video about. I'm not in full agreement with him. I think we should think incrementally instead of thinking that instead of avoiding feature branches completely. But in this case, I think I'm more on his side. But I thought that, I never liked pull requests, but I can't quite articulate why. And so what I hope today is that through a conversation, we'll figure out what we like, what we don't like, when are they useful, when are they not useful. That's roughly the point.
Mm-hmm.
Oops. There's a... Okay, so we fixed the small message that was popping up. All right. So pull requests. What do we like about them? What we don't like about them? First of all, I think it's useful to explain where they come from.
Yes, that's what I wanted to start with, the history and why they are called pull requests.
Okay, go on.
So as far as I remember, the history is that the Git as a system was created by Linus Torvalds. He was managing the kernel changes, kernel updates, kernel new developments through tarballs for something like 15 years. So he would receive tarballs by email, and then he would group them, and then he would accept some of them, send comments back on email. Well, not that friendly sometimes, as his style, about what's going on there. So he would review the tarball, and then he would say, okay, I accept this or I don't accept it. So that was the initial way of working on the kernel of Linux. After that, he says in, I think, a weekend Git, because he knew really well what he wanted. And that's where he formulated this concept of a pull request. The pull request in this concept, in this way of working, means that you have a community, and there's someone like one or a few community managers who say, look, I'm going to approve or not this change that you want to submit to my project or whatever. In this context, the project being the Linux kernel. And then it's a pull request because I ask you to pull this tarball, to pull this change, and put it into the product, into the, however you want to call it, the kernel. So that's how I see it. That's why I know it's called a pull request. Now, after a while, Git got really popular and everybody started using this in enterprise software or in other types of products that aren't community-based, community-focused, in products that are from startups and so on, and started being a bit fuzzy why we have a pull request. But the name remained like that.
Yes, exactly. Yes. So this is the story, and it shows that it was created to solve a very particular problem, and the problem is one of scale, um, a big scale where you have lots of people working on different parts of a code base, which has gotten quite large, and one person who in the end needs to include and merge those changes, approve them or not. Of
So
course,
in a way, what's funny about this is that Linus Torvalds said he created the decentralized way repository, source code repository, but it's a centralized, decentralized source code repository, right? Because he's the center, you'd accept or not, but it's decentralized because you have these branches, so you don't have a server anymore for the repository, but you have a centralized because there's the approver.
yeah, in the end, he was the approver. Now, of course, it's a bigger team there, so there are multiple steps in the approval, multiple people looking at the code. He wasn't looking at everything.
Yes.
But some of the things would go through a number of people, but still, it's a problem of scale, really, because we are talking about a huge number of changes and quite big change sets. And complicated problems, right? It's not like you are adding a new button in a web page. It's more like, we have modified the process scheduler to fix an obscure bug happening on a specific processor or something like that. So very difficult things, and he was getting really frustrated. Well, another thing that happened, he was actually using another decentralized source control system, but they wanted to charge him for licenses, or I think it wasn't open source anymore, something like that. And so he decided, okay, I'm just gonna roll my own because I know this problem really well. I can solve it. Yeah, and this is how we got Git. So what I get from here is that pull requests are good for how would you call this? For
it's a group. It's when you have a big group of where I said the community, right? When you have a community or a big group of developers with small or large, depends, change sets.
Mm-hmm.
The idea is that there are very many of them, and they need to be approved in a way.
Yeah. So it's for what I would say they are good for a big distributed community that is contributed change sets, right?
Mm-hmm.
More or less. And where you need to have some kind of centralized review in the end.
Yeah.
And so for me, okay, let's talk a bit how they are used today, because maybe that's interesting, like in a corporate environment.
Yeah, so you have probably a team, and there's someone doing something, and they say that, okay, I finished my stuff, then I'll make a pull request and let someone else look at it and merge it. And so it's either a team leader or someone else, a team member who would know how to review that, so has enough experience, and would look at it and approve it. So it's part of the code review process as well.
Yeah. So pull request in a corporate environment, every change will be included through a pull request inside the team.
Mm.
And to me, this is where it doesn't make sense, because I guess there's some place in the middle where this might make sense, and I'm just gonna add one, which is accepting changes to a component from an outside, from another team in the same organization.
Yeah,
So,
even though I know, like, from one of our clients that they started like that and they said, no, 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 we were too slow. So they said, no, we're going to scratch all that. We will use trust. So we will change your code. We promise we'll test it enough. We won't do any, we'll use your automated test. We'll create new tests. Okay. We'll test it enough so that we don't produce issues. And there you go. And they work like that for almost 2 years. This is a product. It's a product that changes a lot. And for 2 years, they didn't have much defects on this.
Yeah. So that's why this is a maybe.
Exactly. Yeah.
It's not, always or.
I have a procedural approach, but you can also use the other approach of trust and competence.
Precisely. So, and I guess this is what I don't like, because the alternative to this is trust and clear process. I mean, I'm okay with, and it's perfectly fine for every, let's say we have multiple teams working on different components. The different components could have different guidelines. Okay, because they have different needs. Maybe some of the components need more performance, some of the components need more resilience, security, whatever. So you probably need some kind of a clear process. Now, on the other hand, this process can also be dynamic in the sense that through comments, through conversations, you can teach the teams who are contributing to your component what you actually need. But the most important part, and that's what I mentioned on Twitter as well, is trust. So in an environment like an open source project, let's say I'm starting a new open source project, or maybe I have an open source project, I'm not sure who is going to come and contribute.
Mm-hmm.
Right? Some people might be good, some people might not be that good. Also, some ideas might fit the vision of what I'm building. Some ideas might not fit that vision. So there needs to be some kind of sorting out of what goes in and what doesn't. Now, who does that? It doesn't matter. I mean, it can be one person, it can be more people, it could be, a group of trusted people who are doing this. But in the end, you don't have like full 100% trust with everybody who is trying to make changes from everywhere in the world where they can do. Mm-hmm. And people who you don't know, you've never met, you've never worked together. Of course, you need to have some kind of a process. But in an organization, presumably you know those people, and if you don't know, you can call them, you can talk to them, you can discuss. You can always look at, okay, so they made those changes to our code base. Is there any feedback that we need to give to them?
Exactly.
Right? So it's easy to figure these things out. Also, let's not forget that for open source projects, some people don't work full time on that.
Oh yeah, you can work for a few days and then be off for months, or you can work a lot. And I think also here the thing of trust appears, because if someone works on an open source project and they start giving good software and good results, probably you'd look less on their code when doing accepting the pull request, and maybe after a time you'd like to join the team. So
Yeah,
so
that's
something
also
like
the thing, because I think if I were to, I started a few open source projects in the past 2 years because we actually needed them for our internal purposes, and I realized, oh, this is something that somebody else might need. Actually, Thierry de Pauw is involved in some of them. I gave Thierry full commit and push rights from the very start. There was no, conversation of, okay, should I, shouldn't I, and so on. He can publish the Python packages to the repository. He can do anything he wants with a code base. And this is a clear matter of trust. Now we also got somebody else to wanted to make some changes. We reviewed the pull request. We integrated it. I think Thierry did most of the work, so props to him. And I was thinking, well, if somebody does, let's say, about 3 good pull requests, probably I would give them push rights as well. Because it's no cost. It's no worst case scenario, somebody does some bad changes and we roll things back.
mm-hmm.
I mean, it's not that big of a deal. But I don't expect this to happen anyway. So, but of course, if you have hundreds of committers, it's already a kind of an organizational problem. How do you figure this out, and how do you structure this, and so on? So it can become really complicated for larger teams. But a rule for open source could also be this. If you did 3 pull requests that were integrated without comments, welcome to the team. You now can do whatever. It's so, and it's once again a matter of trust and clear process. Now, so this is one of the problems, right? Trust. And I think you mentioned another one, which was so let's see. Problem number 1, lack of trust, which is important if we want to have to work well together. Problem number 2, speed.
Mm-hmm. It's an overhead. So do you really need it? What is it bringing you?
Speed and bottlenecks. Let's add this as well. Because if you have let's say only 2 people can approve pull requests, one of them is on holiday, the other one has urgent tasks to do, things will not get integrated. It's as easy as that.
Yes. So I think there are situations where you have the team leader doing this, so then of course that's a bottleneck. I don't recommend that unless everyone in your team is juniors, which is already something not that desired. But otherwise, I don't understand why you'd have that. It shows again a lack of trust in the team.
Yeah, exactly. I can understand this slightly when it's between teams, on a case-by-case basis.
Yes.
Right. But I definitely don't understand it inside of a team.
Yes.
So inside of a team, I don't think it makes any sense, because if the team members are making changes to your code that are not desired. Either they break the code or they introduce defects and so on. The way to deal with that is not to have this kind of bottlenecks. The way to deal with that is feedback, right? So the solution here would be, if this is the problem that you're trying to solve, then let's do feedback learning, and some kind of social programming probably help.
Of course. There's also the feedback that is automatic that the pipelines can give to you, because you can have, so okay, there are things that cannot be caught by this, but there are things that can be caught by this, and it's better to have them automatic, like linters, security testing, like automatic testing for features, contract testing. All these things can be put in the pipeline, and they will give the feedback immediately, so you don't even need to care, because the change won't get to be merged, because the programmer who's doing those won't be able to get through because of this automatic feedback.
Yeah, so it's a feedback. Feedback can be on different levels. It can come from tools. It can come from automated, like you said, linters, automated core code analysis, static code analysis. It can come from tests. It can come from a number of different reasons. And then from people.
Exactly.
Particularly on things like architecture or code style or simplify solutions or design. Those are harder to do with automated tools. So, okay. So, I'm not sure if there's anything else to add, actually.
Well, I think there's just a conclusion, maybe, that don't use pull requests, just merge them. There's also maybe, a problem that I see, that these branches are very long-lived, what Thierry also talks in his talk. And so if you have some branches that live for a long time, it's going to be difficult to merge them well without help, without assistance. So that's why maybe the need of a pull request is generated by long-lived branches.
Right. So maybe we need to add this. Never use long-lived branches. And this actually leads to the previous video that I did on this topic, which points to the fact that if you are thinking incrementally, which is, I think, is the biggest problem, actually. I think the core of all these bad practices is the lack of incremental thinking. If you manage to think incrementally, you can take a big problem, split it into smaller problems. For a small problem, you go into small steps and ensure that the code works at every step of the way. And if you are doing this right, you can always commit, probably every 15 minutes, but let's say every hour. Okay, let's not say every 15 minutes. Let's say every hour. Okay.
Yep.
So, and in that case, you can also merge your changes. Some people would like to push directly to the main branch. That's fine. So you could probably do this every hour. But at least you could merge your branches every day. And have branches that live at most 2-3 days.
Yes, exactly. So I think yesterday I had a conversation with on Twitter with Dragan Stepanovic, and I suggested him as a good idea of enabling constraint on the more programming, ensemble programming, that you could have somehow deleted all the branches that are older than, I don't know, 2 hours, 6 hours, 24 hours, whatever you want. And so in this way, you stop having this problem in a more brutal way, let's say. But I think it's enough, that the system deletes automatically one of your branches. You stop thinking about this. Of course, there's way of not doing this, like not committing to the branch, but anyway, the main idea is to do small incremental steps.
Yeah, and believe me, I worked with a company at one point. They are having a branch that diverged from the main line for about a year.
Beautiful.
And they are asking, oh, so how do we merge this? And I said, you don't. It's just throw it away. It's impossible. I mean, it's possible, but you'll spend so much time trying to merge it that it's probably just easier to rewrite and faster to rewrite.
And you can introduce so many defects.
Yeah. So this is why, okay, so it's important to say long-lived branches, 2-3 days.
Yeah, I mean, you choose, but maybe a day would be ideal. Like in an average ideal, can be less, of course, but maybe a few days, not more.
Yeah. When I've worked with feature branches, they were like 2 or 3 days. And that was fine. It also depends on the number of people in the team.
Exactly. And on the dynamic, how many changes you make, and so on. It's dependent on the context, but that's why the more dynamicity, the smaller the duration.
But basically what you do is, so you have the main line, trunk or main or however you're calling it. And then you have branch 1, branch 2, and so on. The key is daily merge main line into branch 1, branch 2, etc. So in this way, when you merge branch 1 into mainline, only 1 day difference. Right? So if you are doing things like this, you'll always have your branch in line with the main line. And then it's easy to merge them because you have a maximum 1 day of difference. Even with this process, and by the way, this is continuous integration. I know that
this is the initial concept of continuous integration.
People believe that continuous integration is the server that is running your builds. No, that's not what it is. This is continuous integration. It's a process. So even with this process, we still prefer a shorter because there's a lot of work here. The alternative is to commit directly to the trunk, which is trunk-based development. That has its own issues because you need to introduce feature toggles and all kinds of other things. So none of these are free, right? You need to do some extra work to make them work correctly. But the key is incremental thinking, actually.
Yeah.
Because if you don't imagine how to split a feature in something that can be finished in 2 or 3 days, it doesn't matter whether you are using pull requests or pushing to trunk-based development. you'll still have a bunch of issues.
Yes.
First, figure out how to split a big problem into smaller problems. That's the general advice. All right. Anything else you'd like to say on the topic?
No, I think that covers it. It's a good summary.
All right. So then I'm really curious what Thierry will do with this. I can't wait to see your talk, Thierry. I hope you'll be watching this. So let us know when you have the slides, when you have your first talk, and we'll link it here just so that people could watch what you came up with and what are the differences and similarities with this. All right. So this is all from us for today. Thank you kindly for the view. And until next time, remember to think, design, and work smart.